Good day, everyone. My name is Doris Bangor, and today I will be presenting about Experiment 7 using a handheld refractor to measure the Briggs and refractive indices of solution. My presentation will be divided in several sections. Here is an outline showing the sections. First is going to be the purpose of the experiment, the experimental procedure, how a handheld refractor works, the result, and also the conclusion. According to the lab, the scientific purpose of this experiment is to understand more about the relationship between the food, solution-based foods, and solid substances dissolved in them. In addition to this, I think some of the other purpose of this experiment is to familiarize ourselves with the concept of refraction, Briggs, and handheld refractors. The handheld refractor. So a handheld refractor is a portable device that measures the critical angle of refraction of a sample. Here is a picture on the screen now that there's a picture commercially available, the HHR, showing the refractor. And also, the device follows the principle of refractometry. When light passes through a different medium other than air, in this case, the sample, its speed changes. Accompanying this is also the change in direction of the light. Using the information that we gather from this, we can establish the relationship of through the Snell's law, where A and B, showing the arrow, are the incident and reflected rays, while N is the corresponding refractive index. Applying this, the HHR calculates the critical angle in the incident angle at which light is refracted at an angle parallel to the phase boundary surfaces. So how it works is that you add a small amount of sample on top of the measuring frames from the source. Light travels through the illuminator flap where it gets diffused at a grazing angle. While keeping the sample in place, light then travels through the sample source at an angle. The measuring frames measure the change of an angle, and the light continues to pass through the device until it reaches the scale, which will be visible to the viewer's eye when you look through. The value in the scale that will be seen through the eyepiece is the Briggs number. This can then be plugged into a formula to calculate for the refractive index of the sample. The experimental procedure. Here's the summary of the experimental procedure. These steps are repeated for the range of the NaCl and unknown samples at varying concentration. And it goes like this. You clean the surface of the HHR, you prepare the sample solutions, you add sample to the measuring surface, You read the Briggs number of sample, and then you record the data gathered, then you calculate the refractive index. This is the table. The table shows the Briggs, the pH, and the various food solutions. Although there's no concrete trend for all the solutions, several items have increased pH values with their increasing Briggs. Number readings, darker solutions generally have a higher Briggs percent. The refractive index of salt water. So this graph shows the relationship between the theoretical refractive indices and various percent of the table salt that we used. So it shows it. That's what the graph is about. And also for this graph on the other hand shows relationship between experimental refractive indices and various percent of the table salt. The generated line for both graphs have the same slope, which is 0.0018, and differ from the 10,000th place of the intercept. Excuse me. In addition to that, the linearity of the experimental graph is close to R2, which is equals to 1. From these, we can conclude that the values are close together. This graph, the iced tea powder, the graph shows the relationship between the refractive index and the mass of the iced tea solution. The generated trend line was y is equals to 0.0019x plus 1.3498 with a linearity of R2, which is equals to 0.9577. This value also close to 1. Therefore, we can conclude that the relationship of the two variables are linear. This agrees with the expectation that increase in the percentage of mass of a solution will also increase the refractive index. So now, in conclusion, HHR is a portable refractor that can be used to measure the Briggs percent of various household solutions. There is no general relationship between the pH and the refractive index. There is a linear relationship between the percentage mass of the solution and the refractive index. Refractive index can be inferred from knowing the percentage mass solution alone. This means that the greater the concentration percentage of the mass of the solution, the greater the refraction index. Thank you all.